One topic students have a difficult time understanding is latitude and longitude. So let's do an overview of that and then talk about the concept of degrees, minutes, and seconds, which is one of the places that can be a little confusing. Okay, so let's first talk about latitude and longitude, the difference. If I were to take a map of the world and get it into a rectangle, so take the globe and make it into a rectangle, because in our lab manual we have examples of it in the globe, so you can read through that. But if that's not making sense to you, let's talk about this on an actual rectangular map. So most people are familiar with the equator, which is that belt around the center of the world. And so this would be our equator on our map. And so this would be considered 0 degrees latitude. And that's because latitude is describing how far away you are from the equator. So they're at the equator, you're 0 degrees away from that. Going north of that, you would go 0 all the way to 90 degrees latitude. And that would be north of the equator. And then you'd have 90 degrees latitude here, so 90 degrees south of the equator. And then you'd have all the points in between. And the degrees comes from this angle. But if you were to say the equator was, say, the equator is like this, and then 90 degrees off of that would be pointing straight up. So if you can picture a globe and it's something circular from here to here, right? So this would be the northern hemisphere. You'd have the North Pole here. This blue marker is pointing out toward the equator. So this is 0 degrees, 10, 20, 45, all the way up to 90 degrees. So you're really just thinking about the angle at which you'd have to make that line that's going all the way around that latitude line. Okay. All right, so if we think about it that way, the North Pole, of course, would be 90 degrees like we just showed, and then you'd have other values in here, like for example, halfway up would be this 45 degree north mark, and then splitting the difference down here, you'd have 45 degrees south. Right? So that's, again, how far away you are from the equator. So we also have the concept of longitude. And so just like there's this belt around the middle of the Earth that we call the equator, there's a line that runs vertically around a particular spot that we call the prime meridian. And so it goes all the way around. And so if we were to think about the prime meridian being right in the center of the map, and then we folded this map around, these two edges would meet on the back side. And so if this is the prime meridian, this would be 0 degrees longitude. And then we go degrees east and west from there. So all the way, and that's not quite centered, but you get the idea, all the way to the back side that would fold around to the back, that would be 180 degrees. So 180 degrees. And this would be longitude. So longitude again, and that would be east of our prime meridian. So that would be east there. And I should label this prime meridian. So P-R-I-M-E, and then meridian. So M-E-R-I-D-I-A-N. All right, so that would be 180 degrees east longitude. And then if I went all the way to the other side, that would loop around to the back, that would be 180 degrees west longitude. Okay. So this is a little different than what you probably see in the lab manual. The lab manual has a globe, and that's a really great way to represent it. But again, if you're struggling with kind of that concept, maybe this will help. It's important to understand that if I were to draw other lines of longitude in here, I might have, like, let's say a 60 degree mark in here, 60 degrees, and that would be east, right? And then you have a 60 degree mark here, and that would be west. And so oftentimes you will see these designations north and south of the equator, east and west of the prime meridian. We also use positive and negative signs for that. So we would consider east of the equator would be positive. So, sorry, east of the prime meridian would be positive. So these would all be pluses, and west of the prime meridian would all be minuses. We don't typically write the plus sign, that's just assumed, but you might see like a minus 60 degrees instead of a 60-degree west. It means the same thing. And then we do the same thing off of the equator. So north of the equator gets a positive symbol, south of the equator gets a negative, but again, we kind of leave off the positive, that's just implied. So this 45-degree line of latitude would be plus 45 degrees or just 45 degrees. This line here to the south might be minus 45 degrees. Make it a little easier to not have to write the N's, S's, E's, and W's. Okay, so that's a brief description of how latitude and longitude work. Now I want to talk about how degrees, minutes, and seconds work. So let's take a look at that. Sometimes it's easier to think about something you already know. So we already know how time works. So if we were to think about an hour, so 1 hour, we can also break that into minutes. And so 1 hour equals 60 minutes. And then also we can think about seconds. So 1 minute equals 60 seconds, or you can convert that to minutes and it'll be 60 times 60, so 3,600 seconds. Okay, so all of those things equal each other. One common thing that someone might do is they might say something like 1 hour and 30 minutes. And so in your head, you know that that means the same thing as 1.5 hours, because in your head you just did 30 minutes divided by 60, because we know that there's 60 minutes in an hour, and so 30 divided by 60 is 0.5, and you in your head added 1 plus 0.5 and got 1.5 hours. So you actually do this conversion all the time, you just don't realize it because we use it so often that it's a second nature. Well, the hours, minutes, seconds kind of works the same way we do with degrees. Let's take a look at how that applies here. Okay, so for degrees, minutes, and seconds, you have 1 degree equals 60 minutes. And then we also say that 1 minute equals 60 seconds. So it's just kind of like time, but we replace the hour part with the degrees. And so knowing that this is the case, let's look at our map over here and think about what is this trying to tell us? And maybe try to find some midpoints, which is similar to something you have to do in your lab exercise. All right, so if I look at this, I first want to say, okay, what are these numbers meaning? Well, they're going to be the latitude and longitude designations. So how do we know which is which? So I first think, okay, what is latitude? Latitude is just describing how far away I am from the equator. All right, so that would be the lines that are running this way horizontally. So for my latitude, if I use this blue line, I know that this is a line of latitude and this is representing a line of latitude here on my map. So which numbers correspond to that? Well, if I look at it, the 33, 52, 30 makes the most sense. It's actually labeled on the side of here. Also, that number's not changing because on either side of the map, it's not going to matter left to right. I'm just talking about north and south. And so this has to be, this 33, 52, 30 has to be my latitude, right? So let's put that LAT. And then if I move up, it makes sense that the 34 degrees would be my latitude as well, because I've moved further away from the equator. So I'm moving north of that. And so this would be my latitude as well. And you'll notice there aren't any negative signs there or positive signs. So we kind of have to just know what to do with that. But because the number increases as you move up the page, it's just assumed that you're going increasing this way, so the equator must be down here somewhere. So now let's look at our other numbers. We have this 11730, this 1173730, and they're the same on the bottom here. So this must be marking my longitude. And so if I draw some green lines here, this would be a line of longitude, this would be a line of longitude. So I'm some distance away from that prime meridian that we just talked about. So let's look. On the right side of the map here, it's labeled 11730. So I must be 117 degrees and then 30 minutes. So the little tick means minutes. The double tick there means seconds, right? So 11730 away from that. And so this has to be my longitude. So I'll write longe down there as a little reminder. And so as I come over to the left side of the map, I see this 117 degree, 37 minute, and 30 seconds. And it matches down here. So now I've increased. I've gone from 30 to 37. So I know that my prime meridian has to be over there somewhere. So even though it didn't label it that it's moving to the west, I would say, oh, this must be west of the prime meridian, or I could use like a negative sign in front and that would tell me that as well. All right, so again, these are going to be my longitudes here. So now that I understand what's going on, one of the things that can happen is sometimes in lab exercises, they want you to find a midpoint. All right, so let's do this one here. We're gonna find this point here. All right, so that point here, the easy part is to think about the longitude. It landed on that longitude, 117 degrees, 37 minutes, and 30 seconds. So that's easy enough. But now I want to think about the latitude. So that was longitude. I think I said that right. This is going to be latitude as we move north and south. So what is that? It's halfway between 33, 52, 30, and 34 degrees. Well, in the prompt, typically it'll tell you what the map is. And so in this map example, it's a 7.5 minute map. So that means that each side represents 7.5 minutes. So this is 7.5 minutes of longitude, same thing with this, and this is 7.5 minutes of latitude, same thing with over here. So I have to figure out what half of 7.5 minutes is, right? So I start down here at 33, 52, 30. I need to go halfway up to here and figure out what that is. So let's take a look. All right, so 7.5 minutes. We would write this as 7 minutes, and a half of a minute is going to be 30 seconds, right? Just like if you have a 7.5 minutes in regular life, you'd just be 7 minutes plus 30 seconds. Okay, so let's half that. So we'd end up with half of 7 is 3.5 minutes, and half of 30 seconds is 15 seconds. So 15 seconds. All right, now it's awkward to say 3.5 minutes and 15 seconds. You wouldn't do that, right? So let's break that down. You would say 3 minutes, and then half of a minute is 30 seconds. And then we still need this 15 seconds here. And now we can add those two together. So we have 3 minutes and 45 seconds. So this is just like if someone said, oh, it's 3.5 minutes plus 15 seconds. You in your head would say, oh, that's 3 minutes and 45 seconds. So same thing here, works exactly like time. All right, so now what we need to do is we need to add this 3 minutes and 45 seconds to this latitude here. So 3 minutes and 45 seconds. That's what we need to add to get to this point of latitude. So let's do that now. Okay, so what do we add it to? Well, we know that our latitude down here is 33 degrees, 52 minutes, and 30 seconds. So let's write that. 33 degrees, 52 minutes, and 30 seconds. And we're adding 3 minutes, 45 seconds to that. Okay, so 30 plus 45 is going to get us to 75 minutes. 52 plus 3 is going to be 55 minutes. And then 33 degrees is here. Okay, so just like in time, you wouldn't say, oh, 55 minutes and 75 seconds. You would round this, or you would kind of round it to the next whole number. So we would take 60 seconds out of here and add another minute, right? Just like you would, 75 seconds is a minute and 15 seconds. So we're gonna do the same thing. We leave the 15 seconds here, and we take the 60 seconds, which is 1 minute, and add it here. So now we're at 56 minutes, and then we still have our 33 degrees. So now our answer is 33 degrees, 56 minutes, and 15 seconds. So that would be the latitude that goes all the way across here. And of course is at that point as well. So that point would have a latitude of 33 degrees, 56 minutes, 15 seconds. And then its longitude would be the 117 3730. So I think that's it. Hopefully that helped, and you can get working on your lab now.